to actually deliver to the market. Very simple example. Now, there are actually many ways to formulate those. One of the ways that is most popular, especially to Mayer and as well to Morris, depending on who you go with, is actually kind of the SMART, and I have adapted it a little bit because I know that there are a few companies in Sweden that are particularly keen on the last A, and I'm a big fan too, so hence it's on my slide. So, so SMART stands really for, so each criteria should be formulated that you can say it's SMART, and SMART standing here for specific, it's detailed, measurable, achievable, relevant, and time limited. This is actually quite important. And then, last but not least, the SMART-A is for agreed. There are as well other hybrids. I think it depends as well a little bit on the company that you actually work in. This gets extended, but this is a good start point. And by the way, the SMART stands as well for another acronym if you're in finance or banking. So be careful. Explain that it's specific and the one. So otherwise there may be confusion on the table if you have that discussion. Then we use, of course, the success criteria to be, well, we measure it and monitor directly or measure through so-called key performance indicators. This is more done than if you have a review process that you're employing. And we come to that closer when we really look at project control and the implementation of the project process. But as a starting point, be aware that there are different times when you're actually measuring for it. Depending on the project complexity or how large it is, it's easier or more difficult. In a complex project, it's actually very difficult to measure that all the time. Sometimes that implies you're imposing measurements and a reporting mechanism from your supply chain or your subcontractors. And depending on how willing they are to communicate, and most of all, can you trust that data? It's a big question. So it depends a little bit on your relationships. But nonetheless, KPIs are the agreed values by which performance of activities can be periodically or continuously measured. I won't give more examples. And then KPIs should be formulated to measure a deliverable, such as a completion of a new product design part, or if you have segments, for a segment, for example. And serves the project manager as a tool to keep a continuous evaluation monitoring process. It's a little bit like a compass. So you could go as far that it's a map. If it's very detailed, very rigid on some projects that may work, then it's very difficult and time intensive to update. But if you use it as a compass that you know you are on the right way, or when everything is delayed, you know, okay, we need more time or more resources, something is not going according to our anticipated plan, then you can use those basically to have, like, if you make it fancy, you can do it with colors. You know, where are we in time? Who's delivering the right parts? Are they actually up to the newest version? Are they matched with the other parts? This is something that you could integrate at that point. Now, we use it as well as a feedback mechanism for performances and activities that we do. There are other tools too. And I had one team that was already keen on this. I hope they find it still interesting. So there are certain ways of benchmarking. What is benchmarking? What do we do here? So instead of coming up with abstract success criteria that we kind of define ourselves, what is benchmarking?
Set the precedence. Just set precedence previous what is expected level.
Yeah. So you compare. You compare to a previous example. You compare maybe to a parallel project. You may compare aspects to other jobs. So benchmarking is a comparison. You set a standard and have a look. The process should be similar. Otherwise, this is a dangerous strategy that may cause stress for the team and so forth. I mean, stress is always a part, but you know, stress that becomes unhealthy is not so good. Stress that kind of encourages people is good, to a degree. Then it could be as well specification. Yeah, so if you work in newer technologies, gadgets or service IT, something like that, you will see it comes often down to specifications. More recently, actually, and we have kind of subscribed to that as a society already. We have actually introduced the game layer. You may notice that in your credit cards you can go now from normal card to silver, gold, platinum, black, without name. That is then, you need a certain income for that. Yeah? And so there are certain elements that are like a reward structure. And what does a game of like that game layer identify with a credit card? They want you to accumulate a lot of money. Yeah, so this is the idea, or spend a lot actually with the credit cards. Yeah? But so game layers, there are many different layers to it, and gamification is another term that is actually quite popular. There are people that are against it, so game layer is probably a keyword that will allow you to find a broader literature on that. And it's thinking as well how you measure, reward. Yeah, so we do that already. It's kind of with skills, and actually Prince 2 you could analyze it. It's as well a game layer. So it's quite hierarchical. You start off as a team player, then you become a team manager, then project manager, then a project sponsor, and so forth. Yeah. So exciting stuff, really. Okay. Quick example. What is LH? Oh, have I written it down? No. What does LHC stand for?
Large Hadron.
Yeah, spot on. Yeah, so quite some time ago, this was 2001. Yeah, we had actually the project being announced, and it was quite interesting because the Large Hadron Collider, what does it do? Does anybody know?
It's a particle collider.
Particle collider? So what does it do?
They smash into each other, and then they measure what comes out of it.
Accelerates particles to its light speed.
Yes. So this is spot on, yeah? You were both right. So it's basically you take particles of an atom, yeah? So we are extremely small here. And by the way, this is a big facility. You accelerate them to nearly light speed and in different direction, and then you crash them in the middle together. And you look what happens. Yeah? With a lot of fancy sensors. And when I say look, it's not so much looking. Yeah? It's like sensors that go beyond our looking. But it makes it then available with fancy translation and interpretation tools and screens. Yeah? It shows us then what happened. Yeah? And then we can deduct conclusions from that. And that was quite pricey, to be fair. And there were actually many reasons why this project started. But the European Organization for Nuclear Research set out to build this facility to discover the Higgs boson through higher energy physics. It's actually quite high. Yeah? This is like kind of nuclear. It's the same like a nuclear power plant. If you put the turbine behind there, and we prefer water, which is not. Okay, let's not get too technical, but it's the same idea. Yeah? So it generates a lot of energy, and it absorbs as well a lot of energy. Now, when people actually started predicting what we are doing there with the particles, there were a few concerns, and you can see them actually here. There was a recognition in 2003, 2005 in media that there may be temporary side effects, could be higher mass objects, and of course, the media is then like, what is a higher mass object? Do I know one? And this was quite unfortunate because they had a real scientist that he hadn't really thought this through, this answer at that point. He pointed out, well, you know, it's what you have probably heard about is kind of like a black hole, a very tiny one. Yeah? And the news agent just dropped the jaw and got really white in the face because what he learned in school class physics, black hole, is that thing that kind of absorbs everything, nothing can escape, not even light. Yeah, so if a planet hits it, it will be gone. Yeah, so this is not a good thing to have if you believe that kind of like simplified notion that you learn in school. And that created then, of course, a big media. Now, the big problem with that was they didn't have necessarily an awareness that stakeholders met that point, because they had actually a lot of delays due to this. There was already a Hadron Collider, by the way, in America, running for 20 years. So just not with the same mass, but anyway. They asked the core teams and core externals instead of championing. So what can you tell us about it? So the senior press officer then pointed out that the test had run successful and the world hasn't been destroyed yet. So it looks funny, yeah? So if you're on that project, you know, it's kind of entertaining. But for the rest of the world, this is terrifying, yeah? What? This is an option? We may destroy our world? This is not a project that I want to fund, especially with like millions of European tax money and like, so we had a lot of private companies that contributed as well, to be fair, universities as well. Leading scientists pointed out it's quite hard to destroy the Earth. So you see, it's kind of funny, but they don't really, the rest of the world had kind of like just the headlines, the world may be destroyed tomorrow when we fire this up. Yeah. So, and Hadrian, so those were actually media news, yeah, and selected newspapers. Yeah. The Hadrian Collider may destroy the world, and then there were even more polarizing ones. Yeah, yeah, depending on which what's your preference on the read was. Yeah? So if you had a fancy newspaper, it was maybe more settled than others. But this is kind of a bad press for you. I mean, you know, at least people start now looking what that kind of project is about. So you could see it as good media, but before nobody was interested. But it's kind of the wrong spin that you want. Yeah. Oh, wait a minute, I'm going here backwards. Oh, I copied it twice. Sorry, this will take time. Okay, I will have to owe you, and this is very sad. I had actually a follow-up. So just to steal it. So oh, this is heartbreaking. I had actually a wonderful slide that must have been eaten by the slide monster or something. I don't know. I probably lost it. But when I copied over the slides from the last session, now we have actually discovered the Higgs boson, which is pretty cool. Yeah. So what we set out, we actually achieved. And this prediction will make it actually possible to have faster computers. Actually, we installed it already. Yeah, so there are practical implications that did come out of it. And although you could say that if we come to media and news media about the project, you would say that they have actually failed to give it the right spin. Yeah? Okay, but I will add the slide into the PowerPoint slide on the ELP. So sorry for that. Okay, we had that already. Yeah, okay. This is different perspectives. Back to the stakeholder. So we jump here a little bit. Be with me with this. Yeah. So this is actually this session advanced. So we have actually 3 slides in. Oh, wait a minute. Shall we have a proper break before that? We were kind of 45 minutes in.
Yeah.
And then start with the stakeholders? Okay, let's do it that way. As well, the proper count in between. Okay, back in 10 minutes, yeah? So we have a, so 5, 2, 1, we start again, yeah? Actually, can you fold this in? Yeah.
No, I'm playing.